Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 2 for May-June 2022, and the code is 9709/61. Let's get started. Question number 1. The diameters x millimeters of a random sample of 200 discs made by a certain machine were recorded. The results are summarized as follows. So A, calculate a 95% confidence interval for the population mean diameter. So from here, we need to calculate the x bar first. X bar is summation x over n, which is 2520 over 200, and you will get 12.6. And then at the same time, we need to calculate the unbiased estimates for variance. Okay, so that is the s square, and the formula is 1 over n minus 1 multiplied with summation x squared minus square of summation x divided by n. Then now when I replace the value, it will be 1 over 199 because your n is 200. Then summation x squared is 31852, then minus square of 2520, then divided by 200. So at last, you will be getting 0.5025. I give 4 significant figures here as the working. Alright, now 95% confidence interval for population mean diameter, which is a mu. The formula is x bar plus minus z alpha over 2 sigma hat over square root n. Okay, so now to get the z value, we have to draw the graph. 95% confidence interval means in middle it is 0.95. Now we know that total probabilities is 1. So here is going to be 0.05 because 1 minus 0.95 is going to be 0.05, but it has two parts. So shared by two parts means each part is going to be divided by 2. So I will get 0.025. So which means the total probabilities towards the left hand side is 0.975. Okay, so now when you refer to the table, the normal table, it will be 1.96 for the critical value. The middle is 0, here is negative 1.96. Then now I will just replace all the values. So x bar is 12.6 plus minus the z value is 1.96. Then now from the formula we need sigma hat, but then we have found the s square. So to get the sigma hat from the s square or the sigma hat squared, we are taking the square root for whole term. So it will be square root of 0.5025 divided by 200. Okay, then now you will be getting 12.6 plus minus the second term is going to be 0.09824. So here I give more significant figures as the working. But then when you use the first value to count, use a minus for the calculation, then I will get 12.5. Correct to 3 significant figures. And when I consider the upper limit, which is counted by using plus, then I will get 12.7. That will be the confidence interval. 95% confidence interval for mu. Okay, now B. Jane chose 40 random samples and used each sample to calculate a 95% confidence interval for the population mean. How many of these 40 confidence interval would be expected to include the true value of the population mean diameter? Okay, so just now, 95% confidence interval for population mean means that 95% the true mean, okay, the true mean will be in the interval with the confidence of, with the probability of 0.95. That is for one confidence interval. But since here he used 40 confidence intervals, therefore the number of confidence interval to include the true mean confidence interval is going to be 40 times 0.95. Okay, because one interval will be with probability of 0.95 to include the true mu. So now you consider 40, therefore 40 times 0.95. So it will be 38. Okay. Now for question 2. Arvin uses an ordinary fair 6-sided dice to play a game. He believes he has a system to predict the score when the die is thrown. Before each throw of the die, he writes down what he thinks the score will be. He claims that he can write the correct score more often than he would if he were just guessing. His friend Lasmi tests his claim by asking him to write down the score before each of 15 throws of the die. Arvin writes the correct score on exactly 5 out of 15 throws. Now test Arvin's claim at the 10% significant level. So basically this is binomial, okay, binomial distribution. So now H naught, the P is 1 over 6. Why 1 over 6? Because 6-sided dice. Alright, so now H1 is going to be P more than 1 over 6. From where we get this? Because he claims that he can write the correct score more often than he would if he were just guessing. So guessing means 1 over 6 for each number. Therefore, he expects he will get higher chance, which is H1 is P greater than 1 over 6. And then now it is 10% significant level, alpha equals to 0.1. So I'm going to write reject H naught. This is a rejection criteria if Px greater equals to 5, because it's mentioned exactly 5 out of 15. Okay, so when Px greater equals to 5 is less than 0.1, we are going to reject H naught. So now our calculation is using binomial distribution. So it is thrown 15 times. Okay, the probability of guessing correctly for each number is 1 over 6, because it is a 6-sided dice, fair dice. Okay, 6-sided fair dice. So now I need to count what is the probability of getting x at least 5. So Px at least 5 when the dice is thrown 15 times. So it's not practical to count Px equals to 5 until 15. So what we do is we just use complementation rule, which is 1 minus p x less equals to 4, because 5 onwards, that is the probability that you need to count. So the complementation rule will be 0 until 4. So now 1 minus px equals to 0 plus px equals to 1 plus px equals to 2 plus px equals to 3 plus px equals to 4. So we need to count all these probabilities. Now for your information, when x is binomial distributed with NP, N is a trials, then P is the probability of success. Probability of x equals to small x equals to, I will write x equals to small x, it will be NCX Px q to the power of n minus x. Okay, so from here, your N is 15, your P is 1 over 6. That means the Q is 1 minus 1 over 6, which is 5 over 6. Okay, then apply this formula and we will be able to get the probabilities. So when Px equals to 0 means that no success. So when no success, in other words, all 15 throws are failures. That means I will be getting the probability of 5 over 6 to the power of 15, all failures. Then plus 15C1, then 1 success, and the 14 are failures. Okay, and so on. So 15C2, 1 over 6 squared, 5 over 6 degree 13, plus 15C3, 1 over 6 degree 3, 5 over 6 degree 12, so that it will be total of 15 for the power. So then 15C4, 1 over 6 power 4, 5 over 6 power 11. Alright, so when you get the total of the brackets, I will get 0.9102. Then here I will get 0.0898 correct to 3 significant figures. So then now I compare, okay, with the rejection criteria. So when less than 0.1, I will have to reject H0. But then now I'm getting 0.08. That means it is less than 0.1. Alright, so here you write since Px greater equals to 5 is less than 0.1. Okay, therefore we reject H0. So when reject H0, go back to the question. Okay, you want to test the Arvin's claim. So there is sufficient evidence because we have rejected the H0. That means it is like supporting the H1. Okay, so it's greater than 1 over 6. Means that he can guess correctly. So there is sufficient evidence at alpha equals to 0.1 to conclude that Arvin has a system to predict the score. Okay, so okay here, system to predict the score when the die is drawn. So just copy. Alright, so that's the solution of this question. Okay, now question number 3. The lengths in centimeters of two types of inserts A and B, inserts A and B are modeled by the random variables X is normally distributed and also Y also normally distributed respectively. So insert A is referring to the X, right? Now find the probability that the length of the randomly selected type A insert is greater than the sum of the lengths of 3 particular chosen type B inserts. Now what to do is here, X is normally distributed 6.2, 0.36, and then your Y is normally distributed with 2.4 mean and variance 0.25. Now you need to find 3 types of B. Okay, therefore I will get 3Y. Alright, this 3 is basically the total, the sum. Right, so I will write the sum is, okay, I will get the expected value first, then it will be easier. So expected of 3Y, it will be 3 expected Y, then it will be 3 times 2.4, then I will get 7.2. Now variance of 3Y, it is sum, okay, because of 3 types, right, 3 same types, therefore it is just total. So when total, we do not square the 3, so it will be just 3 variance Y because of the sum. Then here is going to be 3 times 0.25, then I will get 0.75. Now with this, okay, I will get my 3Y is basically normally distributed with mean 7.2 and variance 0.75. Now the A is greater than the sum of the Y, therefore the X, right, I will just write this P, you need to count P, X is greater than 3Y. So I will move the 3Y to the left hand side to get X minus 3Y is greater than 0. So when X minus 3Y greater than 0, to get this probability, I need to get my X minus 3Y. Okay, so now expected value for X minus 3Y is going to be expected X minus expected of 3Y, which means expected X is 6.2. So 6.2 minus 7.2. It will be minus 1. Okay, then now variance of X minus 3Y, it will be variance of X plus variance of 3Y. So variance of X is 0.36 Then variance of 3y is going to be 0.75. Then we'll add up, it will be 1.11. Okay, so from here I will say that my x minus 3y is basically normally distributed with mean minus 1, variance 1.11. So now, once I have found this distribution, okay, and we need to get this probability, which means I can just standardize it, change to z more than 0 minus 1, which is our mean, then over square root of 1.11, because 1.11 is the variance. Then now you will get pz more than 0.949. Now, when more than 0.949, we have to refer to the graph. This is the normal graph. Let's say here is 0.949. And then now z more than that means that it is towards the right side. Now, when you refer to the table always gives you the result towards the left-hand side. That means this is 1 minus pz less than 0.949. It will be the shaded region. So here I will write 1 minus p z less than 0.949. And then this probability is available in the table. Then now you can just read the table. It will be 0.8287. And now I round up, I calculate this value. It will be 0.1713. Now I round up to 3 significant figures. It will be 0.171. So that is the probability requested in this question. Now for question number 4, the independent random variables x and y have distribution Poisson 2 and binomial 20 and 1 over 4 respectively. So now x is PO 2, Poisson 2. 2 means the mean and variance, alright? So then the y is binomial distributed, mean is n is 20, then the p is 1 over 4. Now, find the mean and standard deviation for x minus 3y. So, ex, okay, basically ex is 2. Variance x is 2 as well. Right? So, for the y, ey, because this is n, this is p. So, we know that expected value of the binomial distribution is n times p, which is 20 times 1 over 4. Then you will get 5. For the variance y, it will be npq. So since we have counted the NP here, NP will be replaced by 5. So for your information, the P is 1 over 4. That means the Q is 1 minus 1 over 4, which is 3 over 4. So from here, I will get 5 times 3 over 4. Then you will get 3.75. Okay, so at last, the mean of x minus 3y, it will be expected x minus expected 3y. Okay, expected 3y is basically 3 expected y. Then I will get 2 minus 3 times 5. Therefore, 3 times 5 is 15. So 2 minus 15, I will get minus 13. That is my mean. Okay, now, before we get the standard deviation, we need to get the variance first. So now, variance x minus 3y will be variance x plus 3 squared variance y. Okay, or you can say it is plus variance 3y. So it is same as variance x plus variance, 3 variance y. Okay, so you can just write VAR for variance or just write V, up to you. So here it's going to be 3 variance y, 3 squared. Okay, so now replace. The variance 2 is 2, variance x is 2, so I better change or I standardize my working. So here I write variance x. Otherwise, you will get confused later on. Okay. Here I will write variance x is 2. Then this is variance, VAR. Okay, now here is going to be plus 9. Variance y, I get 3.75. Alright, now my standard deviation of x minus 3y is going to be square root of variance x minus 3y. So here I didn't count what is the value. So I will just write down here and give you the final answer. Then here now I round up to 3 significant figures. That will be 5.98. So that's the solution for mean and standard deviation of x minus 3y. Okay, now B, find probability of y equals to 15x. So now go back to the definition. Your x is Poisson 2, where y is binomial 21/4. So now your x is Poisson 2, so it means that your x will be from 0, 1, 2 until infinity. So your y is binomial 21/4, which means your y will be 0, 1, 2, 3 until 20. Okay, so now you need to count py equals to 15x. So when py equals to 15x means that now when y equals to 15x, alright, it's only possible when the x equals to 0, your y is 0. Alright, or I will say that when x equals to 1, your y is 15. Just these two values, because if you check, right, let's say here, when x equals to 2, your y is going to be 30 already. So, but then your y maximum is just up to 20. Therefore, we only have these two cases when y equals to 15x. Okay, so which means this probability is same as p x equals to 0, y equals to 0, and plus, or is plus, x equals to 1, your y equals to 15. Okay, just these two cases. So when x equals to 0 and y equals to 0, so now you have to count the probabilities. So now for your information, when x is Poisson mu, okay, your px equals to small x is going to be e minus mu x over x factorial. But then if you are given binomial, x is binomial and p, your px equals to x equals to ncx px q n minus x. Okay, two different formulas. So now remember your x is Poisson. Therefore, the first one is going to be e minus 2 power 0 over 0 factorial. Then multiply with y equals to 0. Y equals to 0 means that no success. So if no success, all failures. Remember, just now I said this is the p. Okay, this is the n. So your failures will be 3/4. So it will be 3/4 to the power of 20. Okay, now the next one when p equals to 1. So replace here, it will be e negative 2 power 1 over 1 factorial. Then you multiply with y equals to 15. So when y equals to 15, so now you replace. It will be 20 C15. After that, the success rate is 1/4 and there are 15 of them. Then the failure rate is 3/4 and there will be 5 of them. Okay, so I need to separate this. Alright, then from here, I will get the total of all this. It will be 4.30 times 10 power negative 4. This is a very small number for this probability. Okay, so done for this question. Now question 5. Cars arrive at a fuel station at random and at a constant average rate of 13.5 per hour. So when you are given per hour means that this is Poisson distributed. Okay. So now A, Find the probability that more than 4 cars arrive during 20 minutes period. So now my X is number of cars arrive per hour. Then now my Y is 20 minutes. So now we know that 1 hour has 60 minutes. Okay, therefore, now at first, from here I will say that the mean of the X is 13.5. Alright, so now from here, mean of the Y, it will be, this 13.5 is for 60 minutes. So now 20 minutes, it will be 20 over 60 times 13.5. That will be my mean of the Y. Then you'll be getting 4.5. That means on average, every 20 minutes, it will be 4.5 cars arrive at the fuel station. Then now, you need to count during 20 minutes period more than 4 cars. What is the probability? So now my Y is Poisson distributed with mean 4.5. Okay, so more than 4 cars means P Y greater than 4. Y greater than 4 for Poisson, we don't have the last Y value because it is starting from 0 until infinity. So when greater than 4 means that it will be 5 until infinity. So I will use complementation rule, which is 1 minus all up to 4. So Y equals to 0 until Y equals to 4. Alright, so for Poisson formula, from the previous question, Px equals to small x, I will get E minus mu power x over x factorial. So that's the formula for the Poisson probability. So now I will get 1 minus, okay, when you look at all this, you have to count all these 5 probabilities. The E minus mu is a constant. Therefore, I can just factorize the E minus mu. So it means that E to the power of negative 4.5. Therefore, the rest I will consider each. So the first one is going to be 4.5 degree 0 over 0 factorial. Or you can just write 1. Okay, plus 4.5 degree 1 over 1 factorial. Plus 4.5 degree 2 over 2 factorial until degree 4 over 4 factorial. So when I count all these values, it will be 1 minus 0.5321, and then I will be getting 0.4679, and now I round up to 3 significant figures. That will be 0.468. So this is the probability of Y greater than 4. Now for B, use an approximating distribution to find the probability that the number of cars that arrive during a 12-hour period is between 150 and 160 inclusive. Okay, now we need to consider 12 hours. So just now, per hour, 13.5. So if 12 hours, that means you have to times 12. Alright, so let W equals to 12x. So now the mean of the W is 12 times 13.5, which means now I'm getting 162. Okay, so for your information, this value is greater than 15. Therefore, we are using normal approximation. Okay, so that's why it's given the hints here using approximating distribution. So we are going to approximate it to normal distribution, which means now W is Poisson 162. So I let this be probably U is normally distributed. Now, for your information, the mean and variance for Poisson will be the same. which means when you approximate it to normal distribution, the mean will be 162, the variance will be 162. Okay, so for Poisson mu, the mean is mu, the variance is also mu. Okay, now we need to get the probability in between 150 and 160 inclusive. So P 150 and 160 inclusive. So since now we need to approximate to U, right, to normal distribution, which means now I need to draw the number line. Now here the Poisson is discrete. Okay, this is discrete. The normal is continuous random variable. So from discrete to continuous random variable, we need to consider the continuity correction. That means either you plus or minus 0.5. Therefore, I need to refer to the number line. Firstly, I will label 150 and 160, and then it's inclusive, and then I have to accept all these values for my W. Okay, so now for the U, I can plus or minus 0.5 from the given values. So it means that it's either 149.5 or 150.5, then here 159.5 or 160.5. So obviously I need to consider the larger interval, okay, to include all the ticks. Therefore, I will write P 149.5 less than U less than 160.5, and then now I will standardize the values. So it will be 149.5 minus the mean. Mean is 162. This is a mean. This is a variance. So over square root of variance. Because when you standardize, the formula is basically x is normally distributed, mean mu, variance sigma squared. The z is x minus mu over sigma. So the sigma is the square root of the sigma squared. Alright, now the middle one should be changed to z, then less than 160.5 minus 162 over square root of 162. So now I will count the values. It will be negative 0.982 and the other value is negative 0.118. So both negative, therefore I need to sketch a graph. Let's say you are getting negative 0.118 and negative 0.982. This is your region. The middle is 0. Here is 0. Now, since both negative, what we need to do is just flip. Okay, so once you flip, this is 0.982, and then the first one is going to be 0.118. So your region is a green color. So obviously, right, to get the green region, actually your blue region is same as green region. So when you need to get the green region, it is the probability of z less than 0.982 minus probability of z less than 0.118. Then you'll be getting the green region. Okay, and green region will be same as the blue region. So now this is going to be P Z between 0.118 and 0.982. It will be the same after you have reflected, and then it will be same as P Z less than 0.982 minus P Z less than 0.118. Then from here, you can just refer to the normal table to get the first probability as 0.8370, and the second probability is going to be 0.5470. So when you minus, the answer is 0.290. Okay, so that is the probability of W between 150 and 160 inclusive. Okay, now independently of cars, trucks arrive. Just now was car, now trucks arrive at the fuel station as random and at a constant average rate of 3.6 per minute period. C. Find the probability that total number of cars and trucks arriving at the fuel station during a 10-minute period is more than 3 and less than 7. Okay, so now for the truck, let it be t. Okay, so the mean per minute per 10 minutes, it will be 3.6 is for 15 minutes. So 3.6 over 15, then you will get 1 minute is how much? Alright, so I rewrite 3.6 for 15 minutes. Then now, when you divide, this is for 1 minute. Then now we need to consider 10 minutes, then you times 10. That will be 2.4 trucks arriving per 10 minutes. Now, for the car, which is the x, so the mean per 10 minutes. So now you refer back to the question. This 13.5 is per hour. Okay, so I will divide this 13.5 by 60 to get 1 minute is how much first. So it will be 13.5 divided by 60. This is for 1 minute. Then I times 10. That will be for 10 minutes. Then you will get 2.25. And then now, the total number of cars and trucks arriving is more than 3 and less than 7. Now I need to get total, means I need to plus. So expected of x plus t. So it will be expected of x plus expected of t. Mean of x plus mean of t, that will be 2.4 plus 2.25. Then you will get 4.65. Okay, and we know that both also Poisson distributed. Therefore, the x plus t will be Poisson distributed with mean 4.65. Variance will be the same value as well. Then now you need to count. This is more than 3 and less than 7. So you need to count p. X plus y is more than 3 but less than 7. So obviously from here, you have to consider x plus y equals to 4 because more than 3. Or x plus y equals to 5. Or px plus 5, x plus y equals to 6, but must be less than 7. So now, again, this is Poisson. Then I will get e negative 4.65. Use the same formula. And I factorize this out. It will be 4.65 to the power 4 over 4 factorial plus 4.65 to the power 5 over 5 factorial plus 4.65 to the power 6 over 6 factorial. Okay, then at last you will be getting 0.494. So that is the solution of this question. Okay, question number 6. A random variable x has probability density function f. The graph fx is a straight line segment parallel to x-axis from x equals to 0 to x equals to a, where a is a positive constant. First part, a, state in terms of a the median of x. Okay, so now I will just draw the graph to have a better idea. So the x-axis, and this is the y-axis. So it will be x equals to 0 to a. Let's say this is a. And it is a straight line. Okay, parallel to x-axis, that means this is the function. Y equals to fx. So from here, we know that the fx is going to be, okay, let's say this is the fx. This is the fa. Alright. So now we know that to have the PDF, probability density function, the total area must be 1, or integration for the function from 0 to a must be 1. The integration is basically referring to the area under the curve. So I know that here is a unit. Okay, that means a times fa is 1. Therefore, fa is 1 over a. So I know that this is basically, right, this is basically 1 over a. Okay, so from here you need to get the median of x. So now median of x, here is the median. So since this is 1 over a, alright, or I would say that this fx is actually 1 over x. Sorry, 1 over a. Yeah, 1 over a. Okay, so the median of x is a over 2, right? Because I know that here is 1 over a, then the area is half. So 1 over a times a number equals to half. That means it must be a over 2. Okay, so that's the median. Now, P, probability of x greater than 3 over 4a. So now, we know that P x greater than 3 over 4a is, okay, let's say here is 3 over 4a. This is 3 over 4a. Alright, and now you need to find area of this. So, the distance here is going to be 1 over 4a. Alright, a minus 3 over 4a is 1 over 4a. Then you multiply with the height. Height is 1 over a. So, this is going to be 1 over a times 1 over 4a. That will be the probability. So, for information, probability is same as area under the curve. So, at last, I will get 1 over 4. This is my a. Okay, now show that variance is this, variance x. So now I will do the integration. Expected x is integrate from 0 to a x fx dx. So here is going to be 0 to a x. The fx is 1 over a, okay, because we already proven here. This is 1 over a dx. And then the a is constant. You can take it out. Integrate x dx is going to be x squared over 2 from 0 to a. And then this 2 can be taken out and joined with the a. So I'll get 1 over 2a. Then now I need to replace my x by a, followed by 0. So I will be getting a squared minus 0 squared. Then at last, the a squared and over a can be simplified. Then I will get a over 2. That is my ex. Now, my ex squared, just use back the same formula, but instead of the x, in the integration, you change to x squared. Then now I will get 0 to a, x squared times 1 over a dx. And then the 1 over a can be taken out because it is a constant. So now, alright, so I will get 1 over a, integrate x squared will be x cubed over 3. Then the limits from 0 to a. Now again, the 1 over 3 can be taken out and combined with the 1 over a. Then now we replace the x by a cubed minus 0. So then the a cubed and the a at the bottom can be simplified. Here becomes 2, here becomes, just cancel off. Then I will be getting a squared over 3. That is my ex squared. Now, variance x is basically ex squared minus square of the mean. So you will get a squared over 3 minus a minus 2 squared. Okay, so at last you will get 1 over 12 a squared. So we have proven this. Right, so this is the full working. Now D, given probability of x less than b is p, and the b is between 0 and half a, then find probability that x between 1 over 3b and a minus 1 over 3b in terms of p. Okay, so now I will integrate probability of 1 over 3b less than a minus 1 over 3b. Okay, 1 over 3b less than x, alright? Sorry about that. So it will be the integration from 1 over 3b to a minus 1 over 3b. Okay, the function is 1 over a, then dx. So now I will factorize the 1 over a and integrate 1. Okay, this is basically 1 after you have factorized the 1 over a. So integrate 1 is basically x. Then now just need to replace the x by the two limits. So firstly, upper limit a minus 1 over 3b, then minus lower limit is 1 over 3b. So now I will get 1 over a times a minus 1 over 3b minus 1 over 3b, it will be minus 2 over 3b. Okay, and now it's given that x less than b is p. So now I need to substitute my b, okay, because I need to get my answer in p. So now I will have to do it here. P x less than b is p. That means when less than b, the limits will be 0 to b, then 1 over a dx equals to p. So integrate 1 over a dx is 1 over a times x, 0 to b, p. So from here, when you replace, I will get b minus 0 equals to p. So this is b over a is p. Alright, so now I have to times in the values. So 1 over a times a is 1, then minus 2 over 3 b over a. Where I times in. Alright, and then I will replace my b over a by p. So then it will be 1 minus 2 over 3 p. So that is my probability. Okay, now question 7. In the past, the mean time for Jenny's morning run was 28.2 minutes. This is a mean. She does some extra training and she wishes to test whether her mean time has been reduced. After the training, Jenny takes a random sample of 40 morning runs. She decides that if the sample mean run is less than 27 minutes, she will conclude that the training has been effective. You may assume that after the training, Jenny's run has a standard deviation of 4.0 minutes. Now state suitable noun and alternative hypothesis for Jenny's test. So now I will write H naught mu is 28.2 minutes. Okay, that is the past records. Now she wants to check whether her mean time has been reduced, which means now you will expect mu is less than 28.2 minutes in your H1, which is the alternative hypothesis. Now B, find the probability that Jenny will make a type 1 error. Okay, now what is type 1 error? Type 1 error is basically P given H naught is true, but then we reject H naught. So that is a type 1 error. Okay, so now when we need to reject H naught, okay, so you look at here, when it is less than 27 minutes, then it has been effective, means that it is reduced. But then when we reject H naught, right, means that it will be x bar less than 27, right? Because when you reject H naught means that you support the time has been reduced. So now I will write P x bar less than 27, given that when the H naught is true, your x bar is normally distributed with 28.2 and variance is 4 squared because standard deviation is 4. over 40 morning runs. So over 40. Because your x is normally distributed, mean mu, variance sigma squared, and then the x bar will be normally distributed, mean mu, variance becomes sigma squared over n. So that's why I divide by 40. Okay, then now here you need to standardize. So it will be z less than 27 minus 28.2 over square root of 4 squared divided by 40. Okay, then here you will be getting Pz less than negative 1.897. Then now I will have to sketch a graph. Let's say here is negative 1.897. Here is the less. Here is 0. Now, to get this probability, I need to flip or reflect it to the positive side. So it becomes A1.897, but the region is towards right side. So it is same as total probability is 1 minus Pz less than 1.897. So here is going to be Pz more than 1.897. It is same as 1 minus Pz less than 1.897. And now I get it from the table, which is 1 minus 0.9711. And now I direct round up to 3 significant figures. It will be 0.0289. Okay, so that's the type 1 error probability. Now see, Jenny found that the sample mean run time was 27.2 minutes. Explain briefly whether it is possible for her to make a type 1 error or type 2 error or both. Okay, so now in the previous part, right, from the B, it's mentioned that when x less than 27, you reject the H naught. So from here, I will write, so given x bar is 27.2. But then from B, okay, reject H naught if the x bar is less than 27.2. Alright? Sorry. Reject H naught if it is less than 27. Okay, from the parts B, less than 27 here. So now your x bar is 27.2. That means that is greater than. Alright? So hence, x bar, now I will say x bar is greater than, but x bar is 27.2, which is greater than 27. Hence, H naught is not rejected. So when the H naught is not rejected, right, type 1 error is impossible, because type 1 error means we reject the H naught based on the definition. Alright, so now from here, type 1 error is not possible. Okay, now what about the type 2 error? So the type 2 error means that H naught is, or I would say that H naught is not rejected, alright, except H naught, when the H naught is false. Alright, so from here, I will say type 2 error occurs when we do not reject H naught, or you will say that we accept H naught. Okay, so from here is mentioned earlier, since it is greater than 27, it is not rejected. So here we do not reject H naught when when we consider type 2 error, which means, okay, hence type 2 error is possible. Type 2 error. Okay, so my conclusion is type 2 error. Wait, my error is missing. Alright, so that's my conclusion. Type 2 error is possible. Type 1 error is not possible. Okay, so that's the end of this video. Thank you for watching. Again, please subscribe to this channel and recommend it to your friends. And not to forget to stay tuned for more upcoming videos. Alright, thank you. Bye.